end-to-end testing. So really what we want to talk about is deterministic tests. Test reliability. There's been a lot of talks already in the today, yesterday, all about test reliability and tests being deterministic. And not everyone understands what deterministic means in this context, so I'll elaborate briefly. A test should pass when the feature being tested is working, and a test should fail when the feature being tested is not working. And it should do that consistently. It should always do the same behavior, right? Now, there's a number of reasons for that. And again, a number of those reasons were already covered in some other talks. But if your tests, don't always behave the same way, then people lose faith in them, people don't stop using them, it tries telling you problems and you ignore them. But I think a more interesting issue, the one that I am trying to get into, is automating the pipeline to production, right? So your entire deployment pipeline. I'm interested in being able to have code merged, have tests run, promote to new environments, run more tests, clear it to go to production, all automatically. And in order to do that, though, the tests themselves have to be deterministic. You cannot have to say, well, some of these tests fail, and I kind of look at it, and then, make some evaluations or something, right? The tests have to do exactly what they're supposed to do all the time. All right. So, why is that sometimes not the case? Now, I'm not going to go in exhaustive detail. I'm going to list just a few common issues. Race conditions. Web browsers are inherently non-deterministic. So having a deterministic test of a non-deterministic system has a number of interesting challenges. The tests themselves are untested. I do not know why it seems okay for people to test the application but not test the tests that are testing the application. Somehow there seems to be a disconnect there, and I don't understand it entirely. If you wrote code, that code's got to get tested. How do you know that it actually does catch the problems when the problems actually occur? Did you force the failures and make sure that it caught them? Intermittent system errors. Well, of course, some of the reasons that your tests don't work is that you actually have issues occurring in the system itself, right? And the tests are like crying, please look, there's a problem, please look. Environmental instability. Destructive tests that are modifying the environment that you're testing in, and then that causes later tests potentially to have problems. Lack of good curated test data, right? People oh, well, there's some production data, we'll just use that. The data changes. Locators, okay, there's a lot of coverage talking about locators and why locators change. Apathy. Now, as I said, these are only a few causes, and some of these may be, in my opinion, a little bigger issues than others, but I am not going to point out any fingers in any of them. But these aren't actually what I want to talk about today, right? I could stand up here for the next 3 hours and talk about all these in quite a bit of detail. But someone pointed out that lunch is happening right after this, and they've asked if we could wrap this up right on time. So with that in mind, I'm going to focus on one very narrow area. So before we get into that, modern web applications are very complex beasts now. I think yesterday morning, Simon talked about, when Selenium started, that the state of web applications was very simplistic, and that if they had tried to build Selenium based on what applications are like today, that it just wouldn't have been possible, right? Because our applications are so complex. So instead of telling you about it, let me show you a few. So these are a few sites that I work with, only a few of them. I just want you to take a quick second and just look at, like, there's a lot of stuff going on some of these. Right? These are not websites like people were familiar with 10 years ago, right? These are applications. They're built up of many, many components and individual, very separate pieces of functionality, right? And they are dependent on lots of other systems and lots of other services. So I could think about, people often thought of like a web application as one thing, right? This is the application, right? But in reality, it's a lot of interconnections. There's a lot of systems that make your application work, right? There's things like identity management, maybe social platforms, search services, advertising services, content recommendation engines, partner integrations, and other things, and other, right? Weather services, who knows what. Again, some of your things may be much simpler, right? But a lot of the ones I work with are very complex. And even if yours are not right now, the likelihood is that it's going to become more complex over time, or your next project will be. So, what does that mean? I like to think of these as a pyramid, right? Your application stands on the shoulders of all these other services, right? And these services are not part of the build that you're testing, right? So I mentioned about the pipeline, right? So I've got like 6 teams of developers all working on one set of applications, and multiple developers all committing and working on tickets all at the same time, and all committing and merging all at the same time. When those things go on, when they make a set of changes, I want to regress the system to see if there was unintended consequences elsewhere in the system so we can clear it and move it on to the next stage. And I'm going to do that quickly, right? So it's really important that these things work reliably, work quickly, but bear in mind that the things that I just mentioned, all these other connected services, are not part of what I'm testing, right? There's a login service or something like that. Well, if that login service just happens to be down, right, I don't want to stop my build, right, from going on to the next environment, because that has nothing to do with the build that I'm testing, right? And what does this really do to our test reliability, right? So every service that we're connected to has its own set of reliability metrics, right? So let's take, for example, you have one service that you're using, and that service is maybe 99.9% reliable. Sounds awesome. But what that really means is that like maybe 1 in 1,000 requests, may have a problem. And when you're running test automation and you're running hundreds of things, and I'm running 10 regressions or 20 or 50 regressions a day, every once in a while, those are going to crop up. But now what if I've got 10 of those services, right? Is it the lowest common denominator? Is my test now dropped from 100% potential reliability to 99.9 with one service under it, right? But if I had 10, right, is it the lowest common denominator, right? Is it the lowest level of service? It isn't, right? They multiply, right? So if you had 10 services that are all 99.9% reliable, my test suite now has dropped to 99% reliable. It's now 1 in 100. Right? Now that is really dramatic. Right? And it gets worse. So if a service, if they promote their reliability standard, 99.9%, right? What does that really mean? So let's take an example scenario. Let's say you're working with Pinterest, or Twitter. Let's say you're working with Twitter. Angie was just here, right? They have, maybe hundreds of servers that are running and handling transactions, right? So I'm running a test. My transactions are hitting the Twitter systems. Now, their system's all automated. They detect a problem with one of their servers, right? They immediately, maybe that machine's gone into garbage collection. Maybe there's something going on. But they recognize that one server is having an issue, right? They kill the server. They build a new one. They put it in its place, right? All great, right? But what happened to the transactions that were in flight on that server? Well, they all got dropped, right? And guess whose transaction it was? It was mine, in the middle of my test suite, which now failed, right? And they didn't mark that as their service being down, right? Because they're like, our server was up, right? Yeah, there was one server that had a problem. We corrected it, and we moved on. We were not down, right? But it caused my test to fail. So, actually, let me segue briefly into a short story. So, going back a little while, I was working with a team of engineers that were working on building out tests. And one of the engineers came to me and said, "Look, I've built this test around a newsletter sign-up. So on all the sites, you can depending on which area of the site you're on, it will detect what area you're in. It figures out what newsletter you want that would relate to that, right? So it should be maybe it's the HGTV Design Inspiration newsletter. And so it's going to recommend that to you. And all you have to do is fill in your email address, and you click sign up, and it sends off and signs you up for that newsletter. It seemed simple enough. But her test was failing pretty frequently in the development environment. Now she was like, well, it seems to work okay in production when we test it against the production system. But on all the other lower environments, this test pretty regularly is failing, and I don't know why. And so I started digging into it. And, we don't know how all this stuff works, right? So you're going through, like, what exactly is it doing, and how does this service work? Well, you find out that, well, what does it do? When you fill out your email address and you say sign up, it's submitting you to a newsletter service. Okay, great. So where is that? Is that part of our application? And it turns out it's not, right? There's some media group that runs and manages that, right? And so it sends a sign-up request. That service then says, okay, we got it. You're now signed up. The module then displays, good, you're signed up. But sometimes it wasn't, right? And in the development environment, I don't know what they were running this on, some sort of like Raspberry Pi or something, I don't know. But the system was clearly overloaded, and they didn't care. It was that was their dev system. Apparently we were integrating, right, all our lower environments with their dev system. And guess what? That sometimes would take 5 seconds, sometimes it would take 30 seconds, sometimes it it just didn't seem to return at all. But it would cause our test to fail because the application, when the browser was signing you up, it would automatically go, if I didn't get a response back in like 5 seconds, something's wrong. And so it would immediately say, hey, there was an error signing you up. It's very, very nicely done on the application side, right? But now the test didn't know what to expect. Okay, so that was one of my introductions into that type of issue, right? This test was now unreliable, or they were calling it flaky, right? And it had nothing whatsoever to do with our application, as application was working great. All right. So we want to deal with these so they're not a problem. So how are we going to do that? What are our remedies? Now, hopefully a lot of you already participated in some of the remedies last night at and if not, I think I'm going to look into that tonight afterwards. So what are the different ways we can do to deal with some of this? Well, I think we could ignore it, right? And there was a few chuckles there, right? Oh. This may not actually be, crazy, right? I think if you're aware of the problem, right, and you're consciously ignoring it, you may have bigger problems, right, than the third-party dependencies that you have, right? They may be a few. You're aware of them now. and it's just not high on the list yet, right? So I don't want to tell you all that, like, man, you have to go solve this, right? There's a lot of other problems. A lot of those are much bigger issues, right? So what if we ignored it? What would be the sort of the pros and cons of that? Well, there's a few advantages, like there's no extra work for us to do. There's no added complexity in our tests. All right, so that sounds really good. But there's probably some disadvantages to this. I'm feeling that some people are guessing there might be some disadvantages to this, right? Well, we may have some random test failures due to these third-party dependencies. And random, by the way, there is no such thing as a random test failure. I get that all the time. Oh, it was a random test failure. No, there is no such thing. It failed for a reason. Don't get me started on that. All right, so what else can we do? Well, maybe we can just try to avoid it. So what would avoiding those third-party dependencies mean? Well, it depends on the service, right? But say it's something like a login. So your test may click on the sign-up link, right? Maybe you verify the form comes up. You know, you populate the fields, you make sure the form and the fields are all in place. But you don't click the sign up button, right, to actually log in. Right? So now you're not subject to that particular dependency, right? You've tested everything right up to that point, right, that threshold, as much as you could, and then you stopped. Right? Okay. So there's probably some advantages and disadvantages to this too, right? Well, again, like with ignoring it, there's really no added complexity to the test, right? Now, you may want to add some sort of commenting about, like, hey, by the way, this stops here for this reason, right? Because otherwise, like, how come this doesn't test the rest of it? Right? It is also really simple to implement. It's more like taking parts of your test out than like having to figure out like what new things to put in, right? There may be some disadvantages. Some of your code may not actually be tested, right? Because like in that login example, when you press that button and you've got the form all filled in, there is still some code that runs. It does something, right, before it actually calls a service. And you skipped that, right? Plus, when the service returns, your application probably does something with that as well. And you haven't really tested that either. So, you know, maybe as a really simplistic step, right, this kind of gets you around those third-party dependencies, kind of makes your test more deterministic, right? But there's the fact that you've left things on the table untested is kind of a problem. So, what else can we do? Well, we can mock the service. And there's a number of different ways of doing that. I'm going to take a minute and talk about some of those. The first one is again, I'm assuming that you have got a lot of client stuff all in JavaScript. So you can do sort of a JavaScript mocking. So that might look like you may have some code, I hope you can kind of read this, but you may have some code that's kind of like this, right? That's about, performing a login, calling a service, right? So there's our, service integration point, right? The vendor has provided us with some, JavaScript code that wraps all that functionality in place and does some kind of callback for me that I provide. So what could we do? We could modify that a little bit. And that's right, I'll highlight this. So first thing we could do is we can add some sort of mocking interface, right? So in this case, this doesn't matter like how you're doing this, but in this case, right, you're taking that service, I'm going to create a mock service for it, and I'm going to define what it does when you pass it certain parameters, right? And then, somewhere you would do something differently with that. In this case, this is really kind of ugly. I'm not sure that you'd really do it this way, right? Instead of like switching one to the other. And if you're really doing this kind of a mock service, you would probably have one sort of identity management thing that sort of switched between them, and you would just, all your code would say, call identity management, and then if you're in test mode, it would call the mock service, and in real mode, it would call the other one, right? And somewhere you're dealing with query parameters or cookies or something, right, to trigger this, right? Now, what's even more interesting, right, is that we can start creating negative cases, right? So we can add some more responses, maybe for negative points, right? So in this case here, we can have some sort of failure data come back, right? And it may not just be, I'm sorry, that was a bad password, right? With the real service, we could do that. But we could also have things like, oh, the gateway timeout error, 503 response. I'm sorry, we're currently overloaded. Can you come back later? We can kind of simulate some of those kinds of things. Like, here's the code you get back for this, and then how do we handle it? Assuming your application hopefully does handle those kinds of situations, right? So that's kind of cool. All right, so what can we do with this? Well, one kind of interesting thing is that you could actually build unit tests around a lot of this code before you've actually deployed it into environments. And then you'd use those same functions as part of your user interface tests. You can cover positive and negative cases, like I already mentioned. That is really, really cool. There are some disadvantages to this. Again, some of your code may still be untested, right? So in that one case, let's say you're calling that service yourself. They haven't provided you with some sort of library. You're making some RESTful calls to a service, right? Somewhere you're like building that REST call and you're sending it, and instead you're saying, just return this response, right? But what if the code that builds that RESTful, call is if that's what gets broken, right? You would not catch that, right? Now we are catching, we're still testing this stuff, on both sides and everything. That's kind of cool. But there's potential for some pieces that might not get covered. So it's kind of important to look at where you're integrating those things into your code base. There is JavaScript coding, which may not be your forte. Hopefully this involves working with the developers of the application, integrating these kinds of things. You may be putting this kind of code into your application in production, which maybe adds a little weight. Could be some other kinds of things. Those are kinds of things to be concerned about. So what other way could we do this? So here's where it gets interesting to me. This is what I like. So we can intercept them. So in my case, I'm using browser mob proxy. Is anyone familiar with the browser mob proxy? I see a few people here said they have. I'm sure there's a lot more. I know Lightbody got mentioned in one of the keynote talks earlier. It's a very lightweight, controllable proxy that you can control via code and stuff. I embed it directly in my test suites, so I can launch it. As when you launch a test, I launch the proxy, and I automatically wire the WebDriver to tell the browser to hook up to my proxy as soon as it starts up. Right? So all the browser requests go through the proxy. And in doing that, I would love to have the time and pull up a bunch of code samples, but I do have there's some time constraints. Plus, there's a lot of different ways of doing it. It kind of depends on the kind of proxy you're doing. I'm using all my stuff directly in Java, so you can kind of work with an embedded proxy, and you can do it directly. You can also do it where it's standalone, and you can just send requests to it to tell it what to do. But you can tell the proxy, when you see this request, I want you to intercept it and do this. So you can have interceptors. And again, it doesn't have to be this particular proxy. There's a whole lot of proxies that all support the same behavior, right? But you can tell it, when you see this request, ignore it. Or when you see this request, here is this JSON data I want you to send back, right? You can do all kinds of things. You could say, wait for 30 seconds, and then respond with this, right? I don't know how to really articulate how cool that really is. But you've now haven't changed in your client code, right? You simply, specify, for certain kinds of tests, like everything else goes through, right? So any other request that you haven't specified interceptor for just goes right through, just as it normally would, right? Except for these ones where you've said, oh, but yeah, that's going to the image server. Yeah, let it go through. That one's asking for, a library. Go let that through. That's coming back to the application. Cool. This one, however, is going out to login. Intercept the login call and provide this user information back, right? I don't have to actually do any destructive tests against the environment. I don't have to actually create a new user every single time to test the new user interface, right? I don't have to depend on there being test users in the production environment, for example. Advantages. I know we can probably go in and talk about catching those for quite a while, but there's no extra JavaScript code, right? No client code that you got to do at all, right? All your application code gets tested. There are no dark corners that you could miss, right, by doing this. You can cover your positive and negative cases, and you can cover a lot of negative cases that are really difficult to do manually, and usually, at least in my experience, get skipped, right? So is your application supposed to do something when that service call takes more than 5 seconds? Do you test that? What if the service is down? Is your application going to do a graceful degrading of that? Did you test that? Does it work? If it worked last week, does it work this week? Right? Those tend to get missed. And then what's worse is when they do break, right? It's like months before someone ever even notices that it's broken, right? Because those kind of code only show up when something else is broken on the other end. It may only be that case for 5 or 10 minutes at a time, and the thing blew up, and then we kind of came back and it was okay. We didn't know what was going on. But meanwhile, that part of your code's not functioning correctly, right? How cool is it to have those negative cases covered automatically? I love that. Okay. We can capture all the service requests, right? So now that you're already proxying those connections, right, you can also just capture them. So now, and I use this, right? So if a test fails, I have all the network traffic for that session, right, just for that test. And I can dump it out, and I'll attach it. And here is a HTTP archive of the network request that happened, right? So I'll actually know, well, this thing failed, but was that because an image didn't load, or the image returned a 404, or there was some call to some piece that was really slow or something? I can go right through the HTTP archive and show the whole little waterfall diagram of all the requests that happened and the performance of them, and I can compare that to what I saw. And sometimes it's really hard to understand why something's broken. And I'm not talking about just the test is broken. The test is telling you something happened, and it's hard to find out in the application why that one thing happened sometimes, right? It's really cool to have that information at your disposal if you need it. All right. There's got to be some disadvantages. It does require a proxy, right? That is now a dependency on your test framework, right? Which means that's some new thing to learn, how to set it up, got to put it together with your system. There is some added test complexity, right? Because now your test is not just your test code. You also have that response code and how you manage inserting that and how you maintain that. Of course, that's all going to be maintained under version control with your test. It's all your tests are in version control, right? The correct answer was yes. All right, that's kind of it for the downsides of this. So if you didn't catch on, I really love doing this, and it's a lot of fun. So all right, so let's move along. End-to-end testing, blindly performing end-to-end user interface testing, tends to lead to third-party dependencies. third-party dependencies tends to lead to unreliable tests. And as we know, unreliable tests lead to the dark side. All right, thank you, everyone. I hope you learned something. There's my Twitter handle if you'd like to send things. I know lunch is coming up right now. I'm going to go ahead and stay here for a little bit. So if anyone actually just wants to ask questions, come down here and we can chat for a few minutes. And with that, everyone enjoy your conference, enjoy lunch.